Over the course of a lifetime, without even thinking about it, we consume and rely upon thousands of products, from the mind-bogglingly complex to the elegantly straightforward. These everyday things are the culmination of brilliant brains working across history in cutting-edge science and design. Beat the horn! I'm Zoe Laughlin, designer, maker, and materials engineer. That's the nylon. And I love getting under the skin of the things we take for granted. I've studied them, but now I'm going to make my own versions.
That looks surprisingly toothbrushy.
To truly understand how form, function and materials come together,
There's a bit of a smell.
I'm pulling apart 3 seemingly ordinary but classic items before crafting my own designs step by step.
Release the balls! Oh, crikey. Vacuum on. Yes.
And constructing something truly bespoke.
They're mad, but they're mine.
In this programme, I'm taking on one of my favourite wearable items and a personal obsession, the trainer.
This is central to the development of sports shoes as we know them.
I am weaving with bacteria.
With up to 65 different parts in a single pair,
This is rapidly cooled.
they combine revolutionary synthetic polymers
It's designed so it's activated with the sweat on your skin, so the food source will be your skin.
with the principles of energy absorption and the biomechanics of how we walk.
We can clearly see loads of load underneath the ball of the foot.
That makes these jewels for the feet, marvels of engineering. Can building my own unique pair from scratch reveal the wonders behind the humble trainer? Trainers come in a huge variety of sizes, shapes, materials, and they're not simply shoes to play sport in. The trainer has become the ubiquitous, casual, comfortable piece of footwear. With the bewildering 5,000 plus varieties of trainer on sale in the UK today, the latest shoes are constantly breaking new ground in material science, engineering and design. There's trainers like these where the sole is made of rubber and graphene, the super material that makes this rubber incredibly strong. There's ones where the upper is entirely wool, so from the high-tech to the kind of ancient. With so many different materials to consider for my own trainers, I'm going back to the beginning, the birthplace of British shoemaking, Northampton. During the 19th century, this was the shoe capital of Britain, with over 1,800 shoemakers set up in the town. Guiding me behind the scenes through the vaults of the Northampton Shoe Museum is historian Dr. Thomas Turner.
So here we are, we're at the sneakers aisle. And if we open this up, we've got loads of hidden treasures.
This archive is home to the largest public collection of trainers in the world.
Oh my word, I remember people in these.
I want to know how trainer manufacturers have produced such varied designs
That's an Air Jordan.
This is an Air Jordan 1 from 1984.
by adapting their materials and how they use them. So what do you consider to be the origins of the trainer?
Well, I think people have been wearing specialist shoes for playing sport for as long as people have been playing sport. And we know that Henry VIII, who was mad about real tennis, had specialist shoes made for him. But I think those aren't really trainers in the modern sense that we'd have today.
So what, for you, is the first proper pair of trainers?
I think you'd be looking at something like, a bit like this. This is a tennis shoe made here in Northampton by William Hickson & Sons from the 1890s. These were mass-produced, made in huge numbers.
It's really lightweight, which is one of the trademarks, I guess, of modern trainers. Like, people want that lightweightness, but it's so slender.
So it's made of specialist lightweight leathers that are designed to suit the needs of people who perhaps want to move around quickly when they're playing sports. But the thing that really sets it apart was that it has this rubber sole on the bottom of it.
Natural rubber is a fantastic substance, tapped from trees in the Brazilian rainforest. It had been around for centuries, but was problematic. It went soft and sticky in heat, and brittle with cold and age.
So there's a man called Charles Goodyear in the United States who's an inventor and an entrepreneur, and he becomes obsessed with this material and he's trying to find a way to make this much more usable. He spends 30 years perfecting the process by which you can make that, but he never makes any money out of it. But he's the one who finds that you have this process called vulcanization, which results in the type of rubber that you've got in this shoe here.
So this is vulcanised rubber. rubber with sulphur added to essentially cross-link the polymer chains and make a much more stable material.
This is where the modern trainer starts. This is the material that starts it off. So have a look at these.
Oh my word, Converse!
This design they'd introduced in about 1917.
This is very, very similar.
Basically what you buy now.
Yeah.
It was rubber manufacturers like Dunlop and Converse that started combining cheap materials like these canvas uppers with their sturdy vulcanised rubber, speeding up traditional shoemaking.
The canvas is much more easily worked than the leather that we saw on the shoe previously.
So actually it's the people who are experts in the material who end up making the shoes rather than shoemakers using rubber.
Yeah, exactly. So the next big development we see is the use of oil-based plastics in shoes. This had been accelerated by the Second World War because you'd had shortages of all kinds of different materials and chemical companies was trying to find alternatives. I want to show you this pair of shoes here. Look at that.
Oh my word, I love how it's presented with the box.
Der schnellste Schuh der Welt means the fastest shoe in the world. So this is the Adidas ROM. This was introduced by the German company in the 1950s, intended to be used at the 1960 Rome Olympics. The thing that sets this apart from everything that had come before it is it has this new dual density foam sole, which made it very lightweight and cushiony.
And you can see here, actually, there is a polymer foam, so plastic with bubbles aerating it to provide just a bit of sponginess.
A bit of cushioning.
Developed in the 1940s, plastic foam is a versatile, lightweight and flexible material and has been a mainstay of trainers for the last 80 years.
So where are Nike in all this?
Now Nike, they begin as a company in the mid-60s and they start importing to America Japanese, effectively copies of these shoes like these Adidas ones that we've just looked at. And they gradually start designing their own shoes and getting Japanese companies to make them. This is one of the
Jazzy.
earliest shoes, a very famous shoe. So one of the founding partners of Nike is Bill Bowerman, who's a track coach at the University of Oregon. And he's obsessed with making shoes that don't weigh as much as a traditional metal spike. And one day he's inspired by his wife's waffle iron in the kitchen to make a shoe that has this kind of knobbly effect on it out of rubber. And they realise that this is really comfortable and they start making these shoes and selling them in vast numbers in the early 70s.
What's exciting you about trainers now?
Something like this coming out.
Yes.
Where you've got this amazing, crazy lattice sole on the bottom, which has been 3D printed.
Because this is essentially made as one complete piece, I love the idea that you could customise this and it's as easy to make a bespoke shoe as it is to make a mass-produced shoe once you start using this technology.
So you go back to the whole idea of these bespoke shoes, a bit like Henry VIII, where you could have a shoe that was individually made for you, but is actually mass-produced, like all the other shoes that we've been seeing today.
So even though there's this incredibly high-tech, futuristic almost 3D printed midsole, at the very bottom here is the vulcanised rubber still.
We've got the rubber that was developed by Charles Goodyear 170 years ago, and it's still at the heart of the sports shoe.
Getting up close and personal with this physical timeline of the trainer shows how material science has pushed forward the development of this extraordinary footwear. But what we can see on the outside is only half the story. To help me in my build, I need to delve deeper.
Sorry, shoes.
And that means cutting them up.
Balls! Everywhere, balls! Oh, it's like someone's popped a beanbag. The foam in these soles has great energy return. Basically, it makes a very bouncy shoe. Well, that is 3D printed all the way through. In the front, where you're going to have more compression, they've got flatter, wider bits, but the heel seems to have a denser area as well.
Just one trainer can require an astonishing 360 processes for assembly, from cutting and sewing to injection moulding. But what about the most basic?
These are what I would call a classic everyday shoe for me. It's a very simple trainer, but it's something I wear a lot of. I find it very flattering on the ankle, but I'd like to see actually what these shoes are made of. Up to speed. Oh, it's pulled it in. Slow and steady. There's something so pleasing and revealing about seeing the innards of something like this. You suddenly understand the object in a completely different way when it's cut in half. You see it as a composite thing that's been made and constructed in layers. Let's have a look under the microscope. There's the fabric that touches my foot. Just below it is a thin sheet of foam.
Next is a large bit of rubber under the instep. The flecks in the material show it's some kind of composite rubber.
Then we go to a more substantial material and then another sort of mat almost. Looks like a bacon sandwich now. And the next layer, this is very strange. It's like a fibreboard or something, almost wool. I guess it's quite rigid. It must give structure to the sole. Then we're on to the actual bit that touches the ground, and that's the sole.
Even in my simple plimsoll, more than 7 materials make up the sole alone.
We have something as simple as this, which is entirely flat, and then something like that where you've got air bubbles and foam and layers, and then again something like this where you have a real complex printed structure.
I haven't got the budget the big brands spend on research and development, more than £500 million a year, or their flashy manufacturing machines. So for my trainers, I'm going to use every ounce of creativity to come up with something that feels unique for me. The 3 basic build elements I'm going to tackle are the sole, the upper, and the fastenings. The best place to start is with the sole. I want to explore how different materials protect my feet when they impact the ground.
One of the key considerations in making trainers is essentially the problem of energy and absorption and impact, the stresses that our feet go through every day, just walking along, even standing still, going down into the ground, let alone dancing or running.
Each time your heel hits the floor, it can absorb up to 8 times your body weight. Trainers combat that stress by providing an energy-absorbent layer, the sole. And that can be designed in a number of different ways.
It's kind of akin to the different types of mattresses you can have. The first being this sort of spring-type shape, where the shape itself sort of deforms and bounces back, rather like the coiled spring in a mattress. So that's like this one. You've got the foam mattress, and in the same way as you have the foam sole. And then you have these air pockets, which is like the good old airbed. Down we go.
I'm going to test how these different materials and structures react to the stress of impact.
So this is basically going down 5 metres into the heavy engineering welding bay.
By dropping a steel ball from a fixed height onto each mattress.
But it's going to provide the perfect pit for a drop test. Time to rig the rulers.
This experiment will help me determine what I'll use in my trainers. By measuring the height of the bounce, I'll discover how much energy is being absorbed by each mattress on impact.
Okay, steel ball number 1 onto the foam. Oh, crikey. Release the balls! Oh! Wow, I thought that was going to go dong and there was going to be a horrendous sound. Nothing. But it's nestled neatly in the foam. It bounced a bit, but it's absorbed a lot of that energy and it's deadened it.
The ball only bounced a little over ½ a metre. That's because the foam mattress is made up of millions of tiny bubbles of air. When the ball impacts the foam, the bubbles are compressed, absorbing the energy of the impact and converting it to heat. That provides less bounce but more cushioning, making it great for repeated, impactful activities like walking.
Right, ball number 2. The bouncy springs. This could go far. That bounced much, much higher than the first.
The ball reached a height of around 2 metres on the sprung mattress. When impacted, the metal coils are compressed but spring back into shape, returning energy to the ball, which causes it to bounce much higher than the absorbent foam did. Perfect for trainers designed for rough terrain.
Okay, onto the cushion of air that is the £10 airbed. Nice. Nothing's broken. Success.
The ball reached a height of about 1.8 metres when it hit the airbed. That's because it contains air under pressure, which reflects the impact energy back. The higher the air pressure, the bouncier it is. Air-cushioned soles work well for running on hard surfaces, such as roads and pavements. But it's the foam I'm most interested in.
He's left a dent. Cute. This one was much more absorbent and really deadened the fall. But that's what you want, in a way, in a trainer, you want a bit of both. You want a bit of bounce, but you also want to absorb the energy. So you can sort of see why all of these different technologies get used in the sole. But when it comes to it, for that all-day comfort, to absorb all of the energy being produced by your feet every time you walk, moving up your bones, foam does a great job at absorbing energy.
I've decided to use foam for my sole, but that only opens the door to more choices.
You can have foams that are very soft, polyurethane foams which snap like biscuits. Here's some aluminium foam faced with carbon fibre, making an incredibly strong, lightweight structure used in the aerospace industry. But they're all characterised by bubbles and cell walls. You can have open cell foams, closed cell foams. In fact, this sponge, you can see this beautiful open cell structure. None of the bubbles are kind of complete. There's gaps, and it makes sense really because the water can be drawn up into the whole structure. Whereas something like a crunchy bar, oh no, that's a whisper. That's a much more closed cell structure. So each bubble of chocolate is its own unique kind of world.
To find a foam that could work for my DIY trainers, I want to know how the big manufacturers make theirs. So I've come to Lancashire.
Ooh. Now you're talking. Serious shoe factory.
This is the UK's biggest shoe manufacturer, producing 35,000 pairs of own brand shoes a week. That's one pair every 20 seconds.
I like the look of this job, the fettling.
It's overseen by Chief Operations Officer Robert Perkins.
Hello, Zoe.
Hiya.
Robert.
Robert, lovely to meet you.
He looks after a state-of-the-art production line where foam soles are injection moulded on huge machines.
All of these moulds are aluminium. They are 3 parts. You've got a side ring for the right-hand side, for the left-hand side, and a sole plate. Now, you'll need to lift this one up slightly to sit.
Oh, I see. Yeah.
And
So
if I do the same.
Oh, a beautiful mould.
There we are.
That's it.
So you can see we've created a cavity, but it's sealed. So when we inject the foam, it can't escape.
Where's the hole?
If you take yours apart.
Yep.
So you see this here.
Oh, I see, yep.
That's the injection port. So we want to inject an exact amount into the mould, and that foams inside the mould, fills the mould.
To demonstrate what takes place inside the mould, we've poured a small amount of the mixture into a cup so we can see the magic happen.
Yeah. So that's all the gas being generated inside, expanding the material, creating a foam.
This transformative substance is polyurethane foam. It's made of 2 organic compounds, an isocyanate and a polyol. When water is added, the mixture forms carbon dioxide gas, causing bubbles, and it expands into a foam.
The chemicals went in at 40 degrees. When they were blended together, they generate a lot of heat.
Well, this is an exothermic reaction, so this is giving off heat as the 2 chemicals react with each other, and then the catalyst is speeding that up.
Absolutely. These liquids have now come together, and you've got this skin.
This is lovely. I mean, this is now polyurethane. Before it was just ingredients. Then they've come together, and now we have this incredible material that's soft, lightweight, self-skinning, perfect for the sole of your shoe.
It's wonderful, isn't it? Wonderful. So let's see the injection point. This is the injection head. The chemicals are mixed at very high speed, so 18,000 revs per minute.
When the mould closes over the shoe, the chemicals are injected in. As they mix together, the polyurethane foam expands, filling the mould.
And there comes a shoe with its sole on it, and there's a bit of flashing that needs to be trimmed, I guess.
Yeah.
But that is direct moulding of polyurethane.
It is.
You've just seen exactly what you're talking about.
It's very exciting,
It is
isn't it?
directly moulded onto the
is.
shoe.
There we are.
Wow, you can still feel the softness. It's got
Squidgy.
that squidgy give, but it's got this really robust skin that's picking up all the detail. It's great stuff. I mean, it's a very clever material. This is doing many things and has enabled you to make an object, well, in 9 seconds, he said.
Per half pair.
Per half, okay, per shoe. I'd like to use polyurethane foam. It's a great material for the sole of a trainer. And unlike mass-produced soles, I have the freedom to play around with my material. I can make a foam, the density of which is going to be just right for me. Ready? Okay, mask on.
I'm taking inspiration from my factory visit, using the 2 key chemical ingredients. Part A is the polyol, and part B is the isocyanate.
This first foam I'm trying, this is the one that's supposed to be the lightest and the sort of bounciest as well. So it's the least dense and the least rigid. Part A into part B. If you change the ingredients a bit, you can actually get a spectrum of softnesses. So I've got about 30 seconds working time. Go, 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 go.
The polyol already contains a catalyst to speed up the reaction, along with a little bit of water.
Okay, and pour.
Together, the chemical reaction creates a polyurethane foam.
This is going to expand in front of our very eyes. It's quite cute. It's hot work under the mask. I'm steaming up.
By trying different concentrations of the mixture,
That'll do.
with exactly the same volume,
I'm on like Tom Cruise in Cocktail.
I'm hoping I'll be able to determine what level of cushioning works for me.
Right, these have had a few hours to set. Definitely set. Here we go. Foam number 1. Number 2. Great to see how varying the ingredients has altered the thickness and the firmness. So even more dense again. Different chemical reactions create different amounts of gas, resulting in this variety of cell structures. Essentially here, the smaller bubbles are made for a thinner, firmer, denser and less spongy foam. And then finally the densest of all the foams. God, this is really robust. This feels really hard. I need something to prise. Oh, something a bit more pokey. That's it. Ooh, and there's our densest foam. It's worth remembering that these were all the same volume of mixture. When these were liquid, they were the same amount of stuff. And now they've expanded, there's a huge difference, especially when you compare the least dense to the most dense. This one's really spongy and this one's quite hard. Right, time to test them.
So which foam will prove most practical for the soles of my trainers?
I'm going to do a sort of Princess and the Pea style test and use a unit of universal terror of things to stand on, the Lego brick. Right, let's place this under each piece of foam. Ooh, it's pillowy. There's the Lego brick. Ow. Bearing in mind, although we're comparing similar volumes of mixture, we're now comparing different thicknesses of material. If this was as thin as the last sample, this is going to be way too thin and I'm instantly going to go, on the Lego brick. This is too soft, I think. Right, let's try the next one. Pronounced Lego brick-age. That's quite painful.
The larger cell structures in these first two create a soft, pillowy effect, but in turn the lack of density provides very little support or protection from the ground.
So I'm now increasing the density, and actually it's coming thinner, but the brick feels as pronounced as it has all the way through. I don't feel supported. That's interesting. This is the most dense foam, the least squidgy, but actually it feels like a shoe sole. It feels quite supportive. And actually I can't detect the corners of the brick. So even though this is the thinnest piece, it's sort of the most comfortable foam. Maybe I'm going for this one.
I've got the right material for my trainer soles, but I still have to work on what shape I want them. And for that, I need to understand how my foot works and what it needs. I've come to meet consultant podiatric surgeon Trevor Pryor.
Hi there, I'm Zoe.
Trevor, pleased to meet you.
Hi,
Why don't
Trevor.
you jump on the couch?
Kick off my shoes.
That would be a good idea.
Now don't worry, I've shaved my toes. Now, I was wondering whether you'd be able to tell me a little bit about feet.
Sure, no problems. We can divide the foot into three main sections: the forefoot, the midfoot, and the rear foot. In the forefoot, you have your 5 long bones, the metatarsals, and they form a joint at the base of your toes in the ball of the foot.
I can do that with my toes, so...
Yeah,
like a hand, I can spread my fingers, so to speak.
and that's pretty good because there's some very specific muscles called intrinsic muscles that help you do those finer movements, and not everybody can do that. So when we move into the middle of the foot, there are 3 bones in here called cuneiforms that are sort of triangular shaped, so they help to form an arch across the middle of the foot there, which provides support.
Almost like a proper keystone in a stone bridge.
Yeah,
those
exactly.
sort of,
That's exactly what it is. So it's really specialist. In the rear foot, a main bone is the heel bone, the calcaneus, and sitting inside the ankle joint is the talus. And these allow the foot to move in this direction, as well as our dorsiflexion in the ankle. Because one of the things the foot's unique for is allowing us to adapt to altered surfaces, so varying terrains. It has to be able to move in lots of different directions, and that's why the foot's so unique to the human. Okay, so if we can get you on the treadmill, please, Zoe.
Okay.
In order to fully understand the dynamic function of my foot, Trevor needs to see me in action.
Okay,
Yeah.
feeling good?
Feels good, feels normal.
Using a system of 99 sensors in each sole, he's measuring the pressure distribution across my foot when I walk without shoes.
Feels funny having to walk to stay still.
And in a pair of brand new trainers. I'm hoping Trevor's data can inform my trainer design.
Okay, so let's have a look at some of these results. Here's your barefoot. Black, blue is low pressure, pink is very high pressure, so you can see how your foot loads through the step.
The barefoot scan clearly illustrates low pressure across my arch as I walk, seen here by the blue and black areas. The ball and heel of my foot are taking the brunt of the impact, shown by the high pressure pink and red areas.
And look, loads of load underneath the ball of the foot.
That's interesting because it really corresponds with the wear pattern that I can see on the soles of my shoes. You know?
And now we put you into our newer shoe, and we can clearly see now that we've got much less pressure.
That band of pink across the ball of my foot is now much reduced, isn't
Exactly.
it? Yeah.
In the trainers, the pressures are more evenly distributed, but they still show my arch is absorbing much less of the impact than the rest of my foot.
That means the material of the trainer is absorbing the energy of that impact and spreading the load really efficiently.
Yeah.
But as I spend hours a day on my feet and often walk over 5 miles, I want to ensure my bespoke pair can more evenly absorb these stresses and strains, and that means more support in the arch.
We know that if you want to reduce the pressure underneath the foot, we can't get rid of the pressure, we send it somewhere else. So for you to reduce the pressure, exactly where you want to get that to go to would be into the arch of the foot.
So if I was able to mimic the landscape of the sole of my foot and make something that fitted it perfectly, that would give something that distributed those forces as best as a material could.
Exactly, that's the best way to spread the load. A good way of thinking about it is you're on the beach, you've got sand of perfect consistency, and the sand gives way to mould to your foot, compared to when you're on a hard flat surface, our foot gives way.
Armed with this knowledge, I'm ready to start making a very personal pair of soles.
It's not bad, I reckon my foot can fit there.
To ensure I'm providing support in my arch as well as the heel and ball,
Hang on, the full stand.
I'm creating 2 moulds so my trainer soles perfectly fit the contours of my feet.
Right, just need to let that set and wash my hands. Hello, foot. It's a positive impression of my foot. It's the positive. And if I build a dam around it and cast foam into that space, I'll then have a foam sole with a negative impression of my foot. It will have my footprint in it. So the foam tests I did earlier have enabled me to pick the sort of foam density I want. But actually using this very craft process of doing it by hand and not having the advantages of an industrial process, actually I have other advantages. I can be more playful, I can be more creative. So I'm going with this two-tone black and white combination. I've got very little time to do this because it all reacts pretty quickly. Here we go, focus. Pour. Oh, missed. And I was thinking of plopping things into the sole whilst it's still wet so that it will bond with the material and then bring added benefits.
All my trainers suffer from wear at the heels, but I'm hoping to solve this problem. I'm cannibalising a graphene-reinforced sole. Graphene is an incredibly strong material. Combined with soft rubber, it creates a hard-wearing rubber composite that's less prone to being worn away by friction.
So I'm going to try embedding that in the heel. And in the workshop, we've got these kind of non-slip kind of rubber meshes that we can put under things to stop things sliding around on shelves. But I was thinking I could try embedding little pads of that to kind of add a non-slip grippy surface. Shoes are often thinner at the front, so actually I don't want it to settle level. I want a little bit rolling to the back. And I guess this is just a test, but we can but see what it's like when it's dry. Can I peel it off the plaster, or has it bonded? Okay. Oh, good sign. Yes! It's a sole, and it looks like a hide of a cow or something. Seeing them both together, it's quite clear that the heel in particular hasn't risen as much as the front. Yeah, putting this piece in, although that's going to add some robustness, it's stopped the foam rising, which is a shame. Either I'll add that on at the end, or I just need to put it in when it's a little bit firmer and has already risen, but is still soft. Right, I'm going to have to stand on it. Let's see how it feels. Sock off. Right, let's give that a try. Oh, yeah. Oh. Oh, I could stand like this all day. Firm, but contoured. Yeah, I think this is going to work as a way of making a bespoke sole.
My next challenge is the upper, a complex part of the trainer. A fabric casing cradling and securing the foot to the sole during movement.
I mean, I don't know how they sew this. There's no way you could run this up on your home Singer. This trainer I find particularly inspiring because actually it's made up of lots of different parts. I love how they make the stitching visible. They're saying, yes, this is constructed, this is part sewn, and we're going to show you that stitching.
There are no limits to the number of materials used in the uppers of trainers.
It feels almost like one piece of wool and it's just somehow become foot-shaped.
Animal-derived materials such as suede and leather can be mixed with synthetic fabrics, plastics and metals for the eyelets.
Let's get the secateurs out. Get all Monty Don on it. Yeah, so that's just open cell foam. This is an object, again, that can enable me to explore different paddings maybe and really make a thing that can be inserted into the shoe that could be different from the rest of the shoe. Whereas the vamp of the shoe, that's the sort of flat top part of the foot. What materials would you want here? Maybe you want to protect the foot, but also maybe you're not wanting the foot to get too hot. So there's lots of questions that are thrown up when you sort of see the differences between these.
One of the latest revolutions in upper design came in 2012 with the launch of the Nike Flyknit. An intricately engineered sock-like upper produced using computer-aided knitting technology. Nike state that their manufacturing process produces 60% less waste than traditional running shoes. Making a typical pair of trainers generates 15 kilos of carbon dioxide, and because they are an intricate composite of many materials, they are almost impossible to recycle. In the UK, 300 million pairs of shoes are thrown away each year, creating a massive environmental challenge. However, there's plenty of research underway looking to address this problem.
Ooh, knitting machines.
Here at Central St Martin's, they're doing exactly that.
Yeah, I'm Zoe.
Material designer Jen Keane is working on an innovative new way of creating very lightweight fabrics.
Oh, I say, you've made a shoe. This is terrific. What's going on here?
So I am weaving with bacteria, and so I've developed a process where I utilize the natural growth of a bacteria called bacterial cellulose, which is derived from kombucha. By learning from the way scientists are studying this bacteria, I developed a process of creating a hybrid material by weaving sort of warp threads and then having the bacteria grow this milky membrane that holds the whole structure together.
Wow, so these threads, you've laid these down in a particular pattern, and then, as you say, this papery thin membrane that's filling in all the gaps, so to speak, that's all grown by these bacteria. That's a cellulose substrate.
The jelly-like cellulose film is a carbohydrate polymer. It's a byproduct of the bacteria feeding on sugars during fermentation.
And in an era where we're all looking to reduce plastic use and find alternatives, here is a material that's making thin sheets that can be reinforced, that can create lightweight structures. Yeah, I mean, that's much stronger than I thought it was going to be.
And if we're looking at products of the future, we're going to need to create alternatives that can degrade into the environment. Obviously, there's waterproofing issues because cellulose absorbs a lot of water.
Jen's bacterial cellulose material points to an exciting future where fabrics can be grown to order with a perfect fit. But because the cellulose degrades in water, there's still more work to be done to turn it into a viable product. Other inventive materials are also breaking new ground regarding how to tackle the environmental challenge.
This is a sample by using a biosynthetic produced strip inspired by the teeth within the squid's suction cups.
Naila Altani has created a glue as an alternative to stitching threads, some of which contain harmful chemicals.
Once you bind the seams together using the heat, you can unbind it using the same process.
So it's a re-gluable glue.
Exactly.
The sequins in Alyssa Brenato's fabric are inspired by the shimmering iridescent wings of a beetle.
When I show these, they're completely dumbfounded that this is a natural material. These really harness through biotechnologies what we can do with nature.
They are made out of wood cellulose, providing a potential replacement for the traditional oil-based plastic ones.
I tried to find a resource that was not finite, so cellulose in abundance, so that it could be compostable.
And cellulose was derived from plants?
Yeah, or also from waste denim, from waste paper, from fruit skins.
Hi, you must be Rosie.
Hi, yeah.
Rosie Broadhead is working on a groundbreaking fabric that might provide some relief for trainer wearers everywhere.
I have incorporated probiotic bacteria into textiles, so when it's worn next to the body, it has a deodorizing effect.
So when it comes to stink, it's not the sweat that smells, is it? It's the bacteria that act on the sweat.
There's different kinds of bacteria on the body, and some are associated with body odor, some are neutral, but we're using particular bacteria that is common on your skin. And the idea of the garment is to add the healthy bacteria to the skin so it will start to colonize and become the dominant bacteria on the body. That's how probiotics work for the gut, and it's the same for your skin. So where you can see these sort of shadows is where the bacteria has been encapsulated.
And what's the food source?
It's designed so it's activated with the sweat on your skin, so the food source will be your skin once they're activated. And that's when they will come alive and start to colonize on your body.
So this is a worn garment. This has gone through all your tests?
Yeah, it's been worn a few times in wear testing trials.
No, nothing? Yeah, passed the sniffage test.
I've washed the garment at 30 degrees and it's stood up quite well to those temperatures, but the idea is because the garment is deodorizing, you may not need to wash your clothes so frequently, and from a sustainability point of view, that's also positive.
Would it be possible to have a piece of this material that you've impregnated that I could then incorporate into my shoe?
Yeah, absolutely. I could give you a piece of fabric.
That'd be terrific. Thank you.
So a promising future for more eco-friendly materials, and great to come away with a fabric that might act as a preemptive strike against any trainer stink. But I need something more durable for the bulk of my upper. Like many trainer manufacturers, I'm looking for something with strength, but also breathability.
Now, I've got 5 different materials here. I've got a natural cotton, a hemp, wool, and then synthetic fibres in the form of a nylon and a Dyneema, which is sailcloth. The first I want to show you is the cotton. Sort of classic woven structure. It's a relatively close weave, but actually there are lots of holes, and those holes are good because they'll let moisture out and keep you cool and dry, but they'll also let moisture in. Well, this is the wool. Now these fibres, these are really hairy. Wool fibres are great because they have a particular structure that means that they wick moisture away, but they also can trap air, so this will really keep us warm. And if we then compare those natural fibres to this synthetic fibre, this is the nylon, now you really start to see a stark difference. It's very, very regimented. The fibres are aligned and packed in really close. This is very, very smooth. And then finally, the Dyneema. So this is the sailcloth, another large regimented weave with no gaps.
Dyneema is a special type of polyethylene that was invented in 1963.
In fact, Dyneema yarn, weight for weight, is 15 times stronger than steel.
Under the microscope, you can see the smooth, man-made structure of the fibres that produce a very strong fabric when woven. As well as sailcloth, it's also used in protective clothing, such as bulletproof vests, but it's very rare to see it used in trainer making.
I'd like to try a little experiment to really see how easily or not so easily moisture passes through them. So I've got 5 beakers, each with 150 millilitres of water in. I want to compare which beaker loses the most water, which loses the least, onto a hot plate. So I'm going to bring it to boiling point to generate steam, and that's going to simulate the evaporation of our sweat through the textiles. And whop it up. I'm going to go hard and fast at first. Oh, they're nearly boiling.
When our feet are trapped in trainers, their 250,000 sweat glands can produce as much as half a pint of liquid each day. A highly breathable fabric is going to allow moisture to escape, reducing the build-up of sweat inside my shoe.
You can see there's plenty of steam coming off the wool sample. In fact, if I put a mirror on it, I can try and capture that. Yep. Already, there's lots of water condensing on the surface of the mirror. In fact, the surface, you can see the hairy surface of the wool is saturated. It's like a dewy lawn. My finger is wet just touching it. It looks to me like the least moisture is coming from the Dyneema. Nothing.
The water has been evaporating for more than an hour, so it's now time to assess the breathability of the different fabrics.
The most breathable being the one where there's barely any water left, and that's the nylon. Then we've got the wool, which I did expect to be breathable, then the hemp. But something to note is the amount of moisture that's trapped in the fabrics themselves. The nylon feels completely dry to the touch, but there's a lot of liquid in this wool itself. This is really holding on to moisture. And the Dyneema and the cotton have both maintained a similar moisture level. This would be the equivalent of quite a sweaty atmosphere, because any moisture that was made inside is actually going to stay in there. You can kind of see why many shoes contain many different materials in their upper, because actually no one material is doing everything.
The synthetic fibres have won me over. I'm going to use nylon for my upper due to its excellent breathability, and the super strong Dyneema to reinforce the toe caps. The next step is to work out how to bring these individual materials together into one single upper. Norman Welsh Footwear in Lancashire have been making their trainers in the same way since the early 1970s. To talk me through the process is Product Development Manager Peter Woodall.
So this is the machine we use to cut out the fabric.
So this is a great big press.
It is. There we go.
The steel cutters work like pastry cutters.
So it's just stamping it out.
It's basically stamping it out, yes.
Well, there we go. And there's the toe.
Would you like to have a go?
Yeah, definitely. Right, bring it on. So this catch releases it.
This one?
I see.
Correct.
Oh, a bit too far.
That's correct.
Yep. Press.
Press.
Oh. Wrong way.
Crazy, isn't it?
It goes quite fast. Yep.
There we go.
There are 26 pieces here, cut from 6 different materials, including suede, leather and PVC, all to make the uppers for one pair of trainers.
What we need to do now is fuse the backer to the fabric, and that will then reduce the amount of stretch that's in that material.
So this is the backer. It's got a bit of give, but actually this is a much more mobile fabric. So fusing these two together will help to add some rigidity to this one.
The backing material is a thin sheet of polyester foam, which fuses with the woven wool upper when heated.
Just to protect it from the heat. And there.
So this is a big heat press, set
It
to,
is,
what, 130-ish?
130.
It says there, 130, 10 seconds.
It's really quite warm, that's what
Still warm, but fused together. So now this is just one piece that can be dealt with as one.
Peter's polyester foam is really useful. I think it could give the lightweight nylon I'm using in my upper some much needed support.
Yeah, because this is my fabric, but you can see it's really pretty flimsy and frays like you wouldn't believe. So if we can fuse this to your backing material, I think it might help stabilise it a bit.
Yeah, let's give it a whirl.
As quick as we can, at as low a temperature as you think will work. Right, let's see.
Aha.
Ooh, yes, I like it.
We've essentially made a composite that could add much more structural integrity to the upper of my shoe.
I like it.
It's really inspiring seeing these shoes come together. OK, I don't have the kit they have here, but I've seen how they cut the different segments that make up an upper.
And I've seen how they treat materials. How do they deal with something that has the propensity to fray?
And I've come away with something to strengthen my own trainers.
Masking tape. This is not the most elegant pose, I apologise.
Taking inspiration from the factory floor, I'm embarking on the next key stage, creating a pattern for my uppers.
Oh, it's quite sharp.
With some extremely low-tech supplies of my own, I'm forming a 3-dimensional template of my foot.
This is sweaty, lovely. But actually with a few cuts in strategic places, I'll be able to lay this flat shape, and it will provide a net for me to make a pattern with. It's already looking a bit shoey. So that's my basic pattern.
This is an opportunity for me to really personalise the trainers, to meet my specific needs.
My next step is to make pieces like this, areas where I can applique onto the shoe Dyneema to add structure. I want to give more attention to the toe area because my big toe is going to work its way through there, no trouble. And that boomerang blob, that's going to be a good bit of protection at the toe.
I'm using the futuristic, bacteria-impregnated deodorising fabric to make some insoles, as the bottom of our feet is where we have the most sweat glands. And now for the tongue.
What do I want to make my tongue out of? I'm quite tempted to use some of the foam I made earlier. This foam wasn't dense enough for the sole, but it's perfect for inside the tongue. I think this will be great. It's like a sliced white loaf.
That's a job well done.
There are many ways to fasten our shoes, the simplest of which is the classic Velcro. Beloved of school children, inspired by nature, invented when a dog walker noticed that their pet had burrs on its fur, and looking at them under a microscope, they realised that the burrs had hooky bits, and it was all about hooky bit meeting fluffy bit, and Velcro was born. There's also magnetic buckles like this that are just, oh, love it. But ultimately, it's the lace that wins the fastening game. It's incredible. It's infinitely adjustable, strong enough, but equally flexible, and it's attached to the shoe pretty easily. You just need some holes.
A feature of shoes for more than 5,000 years, I do like laces, but once I've done them up, I rarely untie them. I just want to slip my trainers on and off easily, so I'm going to make some laces that I never need to untie.
I'm going to use this stuff. This is polycaprolactone, a thermosoft polymer that when you heat up becomes soft and malleable, and then when it's cool is like this. But this stuff is hard and not particularly lace-like. But if I were able to make it thin enough, I think it should then be flexible.
Polycaprolactone is a biodegradable polyester.
This one's going to turn it green and this one yellow.
Its low melting point of around 60 degrees Celsius means that it softens in hot water, but is not too hot to handle.
Hottish, quick roll. Now I need to do a bit of squidging to mix the colour. That's starting to stiffen now. Oh, so I need to put it back in the hot water to melt. Now I want to kind of marble the two together slightly.
Because I can manipulate the hot plastic, my plan is to permanently melt the ends of the finished laces together after I've threaded them.
And then put it back in one last time. I think that's soft enough. And hot, 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 right. And then from that shape, I'm going to draw out laces, rather like optical fibres out of a billet of soft glass. Come on, come on. I thought it would seize up before now, but it's actually got a lot of residual heat in this blob. It's still really malleable. Right, snap that there. It's nice. This is really, it's flexible. Sometimes it's a bit thick and doesn't bend as well as here, for example. This is really nice and, yeah, pliable. I can wrap that round and round my finger. That would be a really good lace. In fact, I'm pretty pleased. For a first attempt, that is a multicoloured ombre polycaprolactone shoelace. I like that.
It's not just the laces I want to have fun with. I've been playing with colours for my foam soles.
Yeah, I like this one.
But I don't have the right shoe-making equipment to assemble my trainers. I'm going to need some help stitching and gluing everything together.
This feels very much like the moment of truth. This is where I find out if all those little pieces I've been working on are going to come together to make my trainers.
Lending me their wealth of knowledge and their machinery are course lecturers Ian Goff and Sarah Day at the London College of Fashion, where for decades they've been training some of the biggest names in modern shoe design.
I've come to this essentially from the point of view of taking shoes apart, trying to figure out how they're made and then putting my own shoe back together again.
Done an amazing job. I mean, this is not an easy thing, putting a shoe together.
The first item I'm attaching are the eyelets, before the industrial sewing machine makes short work of my tongues.
It's going to stick out quite a bit anyway with this, so I'm sort of reluctant to have it too high up.
Yeah, that's fine there, I think.
I'm using the super strong Dyneema to strengthen the heels as well as the toe caps.
We want a bit of reinforcement in the back to help form the shape.
To do that, Ian's using a back moulder with thermoplastic stiffeners.
This is rapidly cooled.
Crikey, suddenly it's looking pretty sporty.
The trainers are moulded around a last and a strip of pliable cork added to strengthen the sole. Then it's all fixed together with a polyurethane glue and a little bit of brute force.
What we've got here is marvellous considering. So we can take those both out now, and there you go.
kind of mad. I can't thank you enough. It's really such a special moment. Thank you.
It's been an absolute pleasure.
Right, treasured possessions. Thanks very much. Cheerio.
Bye.
Right, time for the finishing touches. I want to attach a loop because I like a bit of a loop on the back of my shoe to help yank it on with, and I have made these 2 loops out of the polycaprolactone, out of the same Thermosoft polymer that I've made my laces from. There we go. The little loopy in place. That's nice. Laces. Right, bit yellow, bit green. I like that. Next up, my insoles. So these are insoles I made using that bacteria-impregnated fabric that combat odour. You know, just to be on the safe side. The moment of truth, time to try them on. So shoes off. I'm going to go barefoot because I know it sounds silly, but I want the most kind of intimate relationship with these shoes as I can. Oh, use my little pull-on. That worked well. That was really nice. Already, it's like a cloud. In you go. They're brand new, but they feel about 3 years old in the best possible way. They feel entirely broken in. And that's obviously the result of making it fit my foot.
One final touch, melting together my polycaprolactone laces.
Oh yes, now we're talking. They're so comfortable. It's almost embarrassing how much I like them. They're great. The non-slip's working well, the slippy grippy pad on the ball of the foot, that's the sort of non-slip mat. That's good. I haven't got a mirror, so I can't say for sure that they look amazing, but I feel like they look amazing.
In making my own trainers, I've discovered the huge range of disciplines that come together to create these iconic masterpieces of engineering and design. Despite a few failures along the way, the end result? A slightly bodged pair of very personal trainers.
I like them. I like them. They're mad, but they're mine. And that makes them special.
Next time,
I'm taking on an item so ubiquitous that most of us don't give it a moment's thought, the toothbrush.
they are packed with innovative new materials and technologies.
These are plastic made from sugar cane.
A laser fusing the nylon powder together.
But can I come up with the perfect solution
Hingy.
for cleaning my own teeth?
The moment of tooth. If you want to explore further, watch additional experiments and learn more about material properties and design thinking, go to the address on screen and follow the links to the Open University. They're really comfortable. They make me happy.